Addition of a system of Coplanar forces. So class, when we resolve a certain force into its components, okay, x component and y component, so those components are called rectangular components, okay, and we can express these components to either scalar notation, or we have the what we call Cartesian notation. So let us first discuss scalar notation. Scalar notation, class, can be expressed like this, where your force is the sum of your x component and your y component. So your f sub x here is your x component, or your horizontal component, while your f sub y is your y component of your force, or your vertical component. So how are we going to solve or to get this f sub x, or the x component? You may be able to solve that, class, by multiplying the magnitude of your f to the cosine of the angle that you have. Where did we get this formula? Actually, class, we have taken this from our right triangle. Okay, it's like this. So if we have here a force. For example, this is our x-axis and this is our y-axis. Okay, so let's say this is our force F. So if you want to resolve it, or to get its x component, so we just make its parallelogram, right? Like that. There. So this downward, or this parallel to the x-axis, is what we call the f of x, or the x component. So since this part right here and the line here are just parallel, so this is also our f of x. Okay, while this line here, which is parallel to our y-axis, will be our f of y. Now our force, since it is a vector, so it comes with magnitude, which is the length of this arrow, while the direction is expressed in our angle. Okay, usually it is expressed or with respect to the x-axis, which is right here, or sometimes it is also described with respect to the y-axis. So we can have it like this. Let's name it as angle phi. So angle theta is the angle with respect to the x-axis, and let's take the angle phi as the angle with respect to y-axis. So where did this f cosine theta came from? This f cosine theta, class, was taken from our trigonometric identity. Now, if you could recall from your trigonometry, we have there the common trigonometric functions, which is the sine, cosine, and tangent. If you could recall, you have the SOHCAHTOA, if you can remember that. So represents your sine is equal to opposite over hypotenuse, while your ka is your cosine is equal to the adjacent over hypotenuse, and your tangent is TOA, or opposite over hypotenuse, right? Now, since we are given here, okay, if we focused here, class, in our diagram or our figure or our drawing, so here's our given, which is the function f. So like you said, we have to get the x component. So since this triangle here at the top and the right triangle here at the bottom are just the same, okay, so we can just take this right part, this lower part. So this will be our f sub y, and this will be our f of x, right? This is our f of x, this is our theta, and this is our value or given, which is f. So since our target is the x component, okay, x component, so if we observed from the theta given, f of x is adjacent to that angle. This is adjacent, and this is our hypotenuse, this part right here. So given, or you want to know the adjacent part, and given the angle as well as the hypotenuse. So what do you think? What trigonometric identity is appropriate here? So obviously it will be the cosine, because cosine theta, okay, cosine theta is simply opposite, adjacent rather, adjacent over your hypotenuse. I'm sorry with my handwriting. It's I'm using the mouse. Okay, so in this case, class, our adjacent is what? Our adjacent in our angle is the f of x, or our x component, while the hypotenuse is right here, your value of f. Okay, so therefore, to get f of x, simply cross multiply here, and you'll have the formula f of x is equal to f cosine theta. Okay, so that is where that formula came from. Now, how about for the y component? F sub y is equal to sine theta. So the same class, the same figure, right triangle. So our target is this one, f sub y, and we are given the value of your force. So since this f sub y is opposite our angle, okay, opposite and then given hypotenuse, so obviously the trigonometric identity to be used is this sine, or our sine is sine theta is equal to opposite over your hypotenuse. Okay, there. So in this case, our opposite side is your f sub y, or your y component, and your hypotenuse is your force. Okay, and so in order to solve for the y component, so you simply cross multiply this. So f sub y is simply f, I'm sorry, kindly add here, there should be an f here, class. I'm sorry, there should have f here. So f sub y is equal to f sine theta. Again, kindly correct, there should be f sine theta here. Okay? So again, that is when we are asked to express our components in scalar notation. That is how we solve for that. Sorry. Okay. So you simply get the value of f sub x, and then the f sub y, and then you just use this equation here to express it in scalar notation. Now, we have another method on how to get these components. Like for example, you don't like trigonometry, okay? Or maybe in the problem, there's no angle given, because class, you can only use these trigonometric functions or these trigonometric identities, the SOHCAHTOA, if there's an angle given, just like this. Okay, what if there's none? What if there's no angle given? The only given is let's say slope. Okay, before we discuss that, I want to discuss this part also. I have said earlier, so in this formula here, we have used the theta. So again, this theta is the angle with respect to x axis. We have another angle here, which is angle phi. But class, there are problems that don't use as angle phi. I just use it to represent the angle as y-axis. But there are problems that uses other symbols like beta or alpha whatsoever. Okay, as long as just remember that there exists angles that are with respect to x and also with respect to y. How will you know? How will you know, class? You will know it. It's because it is where the angle was measured. It's like, for example, here. So if he measured the angle from x-axis, he measured, let's say, counterclockwise, just like that. So from here, from x-axis, he started 0 and then going there, so he measured it. Okay? So that is with respect to x-axis. But if he measures the angle from the x-axis like this, from here going here, can you follow? So it means that starting here from the y-axis started 0, and then going there, it will become positive. Let's say this is positive 30 degrees. Okay, that is when we can say that he measured it from the y-axis. But if he started from the x-axis, started measuring from the x-axis, so we can say that he measured it with respect to x. Okay, now going back. So like I said, in this figure, theta here represents the angle that is measured with respect to y-axis. Now, will we have the same formula if, for example, we use the angle phi in solving for f sub x? No, we will not, class. We will have a different formula. Okay, let us analyze. So we will take this triangle here. So this will be like this, contrary to what we have earlier, which is this common right triangle. So in this case, this will be our right triangle, where this hypotenuse is our f. Okay, this is our angle, which is the angle phi. Okay, angle phi. There. So obviously, class, in this figure, our x component is this part. Okay, always remember that x-axis or x component is horizontal. But class, there are also problems that doesn't use x-axis and y-axis. There are other problems that uses other letters, like for example u-axis or v-axis. Okay, so it's important that you of course you adjust with the representations. Anyway, they are just the same. In this case, our x refers to the horizontal axis and y is for vertical axis. Okay, and this one right here is our f sub y. Now, applying the trigonometric identity. Okay, how are we going to solve for the f sub x? So, analyzing, f of x is what of your angle? Is it opposite or is it adjacent? Obviously, it is opposite. So therefore, in order for you to solve for f of x, you will be using sine. Can you follow? So your formula will be sine phi. Take note, class, instead of theta, we will be using now angle phi because that's our angle here. So sine phi is equal to your opposite side is your f of x and your hypotenuse is your f. So therefore, to solve for f of x, your formula, class, will become f sine phi. Can you follow? Observe, class. F of x, f cosine theta, but in this case, f of x is f sine phi. Okay? See the difference, class? The same quantity that we are solving, but different formula. Okay? Again, this changes only happens because of the angle. So again, you will only use this formula if your theta here is with respect to the x-axis. And you will only use this if your angle is with respect to y. Okay? How about for the f sub y? So looking at the figure here, your f sub y is adjacent to your angle. So obviously, it will be your cosine. Cosine phi is your adjacent is f sub y and your force, which is your hypotenuse. So therefore, class, f sub y is f cosine phi. Cosine phi. Okay? So take note also of the difference there, f cosine phi, and here this one, f sine theta. Okay? So that's class, one way on how we could solve for the value of our x and y components. Now there is another way, just like I have said. Another way is by using our slope. Okay, so now take a look at this. Okay, so this is our given earlier. Okay, we are given the force, and then we are given the what do you call this? This f theta. Okay, Now, what if we are given this one, the second picture, where instead of theta, okay, earlier we are given the theta, this one, so we can make use of the trigonometric identities, the cosine and the sine. Well, in this second picture, instead of theta, we are given the slope, which means the rise and the run of that line. Okay, in this case, the rise is your B and your run is your A. And take note, class, as you can see, it makes also a right triangle where your C represents your hypotenuse. Can you see it? Okay, so based from this figure, class, how are we going to solve for the value of f sub x and f sub y? How? Okay, can you recall the similar triangles in your geometry? Yes. Take note, class, in our subject, we have to review all our foundations in math, your algebra, your trigonometry, your geometry. It's very important, class, that you familiarize our rules, our formulas back there. It's because, like you said, it's a foundation, and we will be applying it here in our engineering, especially in our computations. So going back, based from your geometry, okay? So as you can see here, we have a small triangle here that is formed by our slope. This is a small right triangle, and as you can see, class, okay, it is similar with this big triangle. Can you follow? The small triangle formed by the slope is also similar. Now, applying the ratio and proportion. Okay? So if this part right here, okay, since this is parallelogram, so this f of x is just equal here, there. Okay, so this is also f of x, and this part right here is just parallel here, so they are the same na f sub y. Now this hypotenuse, big hypotenuse here, is our f. Okay, now your target is f of x. Okay, your target is f of x. So solving for what? F of x. So we will be using the similar triangle. So to do that, so you focus on this side. This is the adjacent side of your right triangle. So f of x. So what is its proportionate part or similar part on the small triangle? It is the side A. Can you follow? In the small triangle, the adjacent part is the side A. In the big triangle, it is the f of x. That's why we have here f of x is proportionate to your side A. This is the small triangle, and this one is in the big triangle. Now, of course, when you do this ratio and proportion, you have to make use of also of the given. Okay, because we have something to solve. So of course you need to make use of the given. But you cannot use both of the unknowns because there's none that you can solve from it. So since in this case your f is given, so you will be using the side f, which is the hypotenuse, of course, right here, the big triangle. Now in the small triangle, the equivalent side is your side C, which is here. That's why we have C here. So as you can see, from here, we'll be able to solve for your f of x. How? You'll be able to solve for f of x by simply cross multiplying this, and you'll have f times a over c. Okay? That's it. While for the y component, you have here this one. Okay, this is your f sub y. So you have to focus here at this side, which is the opposite side. So f sub y, the similar side on the small triangle, is your side B. That's why we have f sub y and side B here. Now take note, class, of our f. Our side f here is also similar to our side C. Now, if you can notice, there's a negative sign here. What does the negative indicates? What do you think, class? The negative, class, indicates that our f sub y is going downwards. Actually, the negative should be here. Yeah, it should be here. The negative, class, indicates that your f sub y is downward. If you go back, or if you analyze the figure, as you can see, the arrow of your f sub y is going down. Now the question, ma'am, why didn't we place negative on f sub x? We didn't put a negative sign on the f sub x, class, is because, as you can see, the arrow of, or the direction of your f of x is to the right. Okay? Always recall that, or always remember that sign is very important here in the components. When the direction of your arrow is going left or downward, so automatic it is negative. But if it is upward or to the right, it will become positive. So based from here, class, your f sub y will then become negative of f times your b over c. Okay? Or anyway, class, it's okay if you don't put the negative, as long as later you're gonna place it, the negative, to indicate the direction of your component. Okay? Anyway, we'll be having examples regarding that. So another way on how we could express this rectangular components, class, is by Cartesian vector notation. Okay? And in this type of notation, we will be using this format where your x component will be multiplied by I, and your y component will be multiplied to j. So if you could recall, class, in your physics, this I, j, and there's another which is the k, these are called the unit vectors. And if you could recall, this represents the direction. Okay, recall that a force both have magnitude and direction. So in this case, your f of x refers to your magnitude, while your I, that's the direction along the x-axis, while the j, that is your direction along the y-axis. And if we have a three-dimensional figure or three-dimensional axis, so there's another k there, but right now we only have two axes, I and j. Okay, so all we have to do is follow this format with your I and j as their direction. Okay, now how are you going to solve for the resultant of a coplanar force? When you say coplanar force, class, these are forces that are within the same plane. When you say coplanar, they are plotted in the same plane, just like this in figure. As you can see here, there are three forces, F sub 1, F sub 2, and F sub 3, and they are on the same plane. Okay? They are plotted in the same plane. So, in order for us to determine the resultant, when we say resultant, the sum, okay, when we add these forces, is because, class, from our previous discussion, we only get the result or resultant of force which involves two forces. So in this case, what if there are two or more? In this case, there are three. So what will be the method on how to get the resultant? Okay, so if you could notice, okay, so this f sub 1, f sub 2, and f sub 3, they are in a coplanar or the same plane. So as you can see, these are 2D or two-dimensional. We have x and y axis. So if we analyze, there are x and y components in each force. So f sub 1 has its x and y component. Your f sub 2 also have your x and y component. The same with your f sub 3. So from that, if we know their, or if we solve for their x and y components, so we may be able to use them just like this. you get their x and y components, and from that, we can express them either in scalar or in Cartesian vector notation. So if, for example, we want to use the Cartesian vector notation, okay, so using the x and y components of each force, so obviously we'll be having three equations of our forces expressed in Cartesian vector notation. So for f sub 1, okay, so we'll have there f sub 1 x, which refers to the x component of f sub 1, and then multiply with the unit vector I, so plus your f sub 1 I y, which is the y component of f sub 1, and then multiply to j. Okay, simple as that. You just follow the format. Okay, you only have to solve for the x and y components of each forces and then put it there in the format. The same with f sub 2 there. Take note, class, that our f sub 2x is negative. Why is that so? Look at here. Look at this part right here. F sub 2x is here, okay, which is towards the left. What we have said in our previous discussion, that is very important that we bring the direction of each of the components, or the signs rather, if they are going to the left or downward, so we need to put negative sign. But if they are upward and to the right, then they are just positive. So in this case, your x component of f sub 2 is to the left, so therefore we have placed here negative sign. You will notice that our f sub 1x and f sub 1y are both positive. It's because f sub 1x is to the right and your f sub 1y is upward. Okay? Now, how about for the f sub 3? By the way, your f sub 2y is to the upward. Okay? So therefore, it's positive. Now, how about for f sub 3? There. As you can see, in the f sub 3, your x component there is positive, is because it is going to the right, while your y component is negative, it's because it is going downwards. Okay, so simple as that, class. Once we knew the x and y components, then we can express it easily in Cartesian vector notation. Okay, now here, class, since we have expressed already the forces in Cartesian vector notation, so in order for us to solve for the resultant, okay, so simply we will apply the vector addition, right? Now, since we are adding vectors, so we cannot just simply have it f plus 1, f sub 1 plus f sub 2 plus f sub 3. No. Okay, recall that we are adding here vectorially, which means that whatever the values, so it will not be automatically 1 plus 1 equals 2. No, it's not. Okay, as you can see here, the f sub 1 here is here. Notice the value of f sub 1 here is f sub 1x I plus f sub 1y j, while for the f sub 2, we have here the value, and f sub 3, which is this, which was expressed earlier, right? Now, how are we going to add this, or how are we going to combine these figures here? So we will just we will just apply the similar variables or similar terms as we have known, like for example in the algebra. So we will add all terms that have I, and we will also add all the terms that have j on it. So that means in this case we will add f1x negative f2x and f3x y. It's because they have I on it. Can you follow? Just like for example, class, 3x plus 2x plus 5x. You can add them, right? Because they are both having x term on them. you cannot add x plus y, right? Because they are different terms, just like this. So you can only add those that have the same i's on it, or the same direction, which is I. So as well as for the j, so we will add f1i, f2y, and this negative f3y for the j. So the resulting is like this. So you'll just factor out the I and the J. It's because, like you said, they have the same direction, which is I and J. Okay? So from that class, you'll be able to solve for the resultant. So you simply combine all the x components, or the x components, and you simply combine also the y components, and then just put I and J. Okay? Or summarized is, in order for us to solve for the resultant force, or the F sub r here, so we simply what? Get the resultant of the x, which means you add all the x components and then just put I. And then add also all the y components and then put j. Okay? Simple as that. There. So how about for the scalar notation class? Okay? So for the scalar notation, we'll have this there. So unlike what we have done earlier, it's somewhat the same class. As you can see here, we have here the sum. Okay, notice here f1x minus f2x. By the way, this is plus kindly correct, plus f3x. This refers to your frx. Okay, now notice here in our scalar notation, there, it's the same, right? It's the same. The only difference is that it doesn't have I on it. Because class, if you could notice, scalar represents to what? Scalar only means magnitude only. So that means we don't have direction here. We don't use the I and the j, only the magnitude. So for frx, you simply add all the x components, while for the y component, resultant of the y component, so you also add all the y components. Or simply class, to summarize, in scalar notation, you simply have to get the summation or sum of all the f of x, or the x component, and for the y, sum of it also. Take note class, we have to use positive and negative for the directions. Like we have said, if it is downward and to the left, it should be negative, but if to the right and up, it will be positive. Now, this is the magnitude class. Okay? Magnitude of the resultant force. This is how we solve for the magnitude. As you can see, this is somewhat the application of the Pythagorean theorem, because that's, if you could recall, like this, if this is the let's say this is the force, if this is the this one, if this is the, I'm sorry with my line, if this is the F sub r, okay, if this is our target, and we have solved for the frx, which means this is already this is the x component of the F sub r. So if you could recall, this is somewhat like this. This is the F sub rx, right? And this F sub ry, this is already his y component, which forms a what? Which forms a right triangle. Okay? And if we apply, since our target is to solve for the magnitude of F sub r, given this, why did I say that frx and fry are given? Because class, it can be solved easily by simply summating all the f of x and summating the f of y. So our target is to solve for the resultant force, which is taken by applying the Pythagorean theorem. What is the Pythagorean theorem? Pythagorean theorem is hypotenuse squared is equal to adjacent squared plus your opposite squared. So in this case, our hypotenuse is your f sub r, your adjacent is your frx, and your opposite is your fry. Now, why did we get the radical of it? It's because this is squared. So in order for us to get only the f sub r, so we have to get the square root of this, both sides. That's why square root of fr squared, so we have fr here. Okay? So again, this is only the magnitude. Now, how about for the direction of your resultant force? So, unlike in the Cartesian vector notation class that we express our direction as I and j, so in this case, in scalar, we will express it through theta, okay, through an angle. So in this case, if this is the angle, so how are we going to solve for it? If we have the values of fry and frx, what trigonometric identity can we use from it? So if you could recall, we have the trigonometric function, which is the tangent. Tangent is opposite over adjacent. So applying the tangent class, tangent theta is, you have opposite over your hypotenuse. Okay? So in this case, what is your opposite side? Opposite is your fry. Okay? fry. And your hypotenuse is what? frx. Okay? So in order for you to solve for the theta, you will simply what? Get the arctangent of the expression fry over frx. Now take note, class, that frx and fry can be positive or can be negative. It's because it could the negative there indicates that it could be, it is to the, if for example your fry is negative, so that means it is downward. But if for example your frx is negative, so that means it's to the left. Okay, it indicates direction. So you have to indicate that negative there. You have to follow it. Okay, so that's it, guys. That's the how we will express our, or how are we going to solve for the resultant force using scalar notation. So again, in scalar notation, all you need is the magnitude fr, this one, and your theta. While for the Cartesian, so you simply express it with I and j.